Okay, let's do some sampling without replacement. So this is very similar to what we've already been doing with our tree diagrams and then using the tree diagrams to work out the probability of something happening. But there's just one small difference. And it shouldn't be too hard to follow if you think about what's happening here. So I'm going to base this off an example in the book. And let's imagine what we have here is some sort of container and it has some marbles in there. It has some blue marbles and some green marbles. There are 4 blue marbles and 5 green marbles. So let's imagine someone reaches into this container and pulls out a marble and they look at its color. They note the color, they put it down and they don't put it back in the container. So they have not replaced it into the container. So this is sampling without replacement. Then they reach into the container again and pull out another marble and look at its color. So let's start by representing what's happening with a tree diagram. So the first thing that happens is they reach into the container and they pull out a marble. One of two things could happen. It could be a blue marble or it could be a red marble. So we'll start that by representing that with 2 branches on our tree here. So it could be a blue marble or it could be a green marble. And there's a probability of either of these things happening. So the probability of pulling out a blue marble is, well, we have 4 blue marbles out of 9 marbles altogether. So there is a 4 in 9 chance of getting a blue marble and a 5 in 9 chance of getting a green marble. So this is the first thing that happened. This is our first marble. Like I said before, they pull the marble out and they don't put it back. And then after that, they pull a second marble out. So let's imagine the first marble they pull out is blue. So we'll follow this branch here. They then reach in and they get a second marble out. 2 things could happen again. It could be blue or it could be green. Now, thinking about what's already happened, they've pulled one of the marbles out, and this particular branch that we're working on is the branch where this first marble was blue. So they've pulled one marble out, so there are only 8 marbles left in the bag. And because they've pulled a blue one out, there are only 3 blue marbles left in that bag. So there are 3 blue marbles out of 8 total marbles left in this particular bag. So that's one thing that could happen. We could get a blue marble and then a blue marble. So we started with 9 marbles in the bag with 4 of them blue. We took 1 blue one out, leaving 8 total marbles in the bag and 3 blue marbles left in the bag. What about the chance of getting this green one? So we pull out a blue one. There were 8 left altogether. And we started with 5 green marbles, and that hasn't changed because we haven't pulled any out yet. So we go 1 blue and then 1 green, and there's a 5 out of 8 chance of getting this green. So the other possible thing that could have happened is the first marble could have been green. We take it out, we look at it, we don't put it back. 2 things could then happen for our second marble. It could be blue or it could be green. And again, now we assign some probabilities to this. We go, okay, we had 5 out of 9 marbles being green to begin with. We've taken a green one out, so there are 8 marbles left. And there are still 4 blue marbles in there because we haven't touched the blue ones yet. Or we could have pulled out the green one and then pulled out a second green one. So we follow this branch. The chances of the second green one happening, well, there are 8 marbles left in the bag. We've taken one of the green ones away, so there are 4 green ones left. So that's how we set up this tree. So remembering that because there is no replacement, when we get to these second branches here, there are only 8 marbles left in the bags. Next thing, some of the questions you might get would be something along the lines of, what is the chance, or what's the probability that you will pull 2 marbles out of the bag, or 2 blue marbles out of the bag? Well, what we do then is we follow our tree diagram. We go, okay, there's 1 blue marble, 4 out of 9 chance of that happening. And then the second blue marble, 3 out of 8 chance of that happening. Then what we do with these 2 probabilities here is we times them together. So the probability of 2 blue marbles equals 4 out of 9. So that's our first blue marble, times 3 out of 8. That's our second blue marble. Which then that equals 4 times 3 is 12, and 8 times 9 is 72. So 12 out of 72. Next, you could be asked, what's the probability of getting 2 marbles that are the same color? So now we have to look at separate branches of this tree. How many of these outcomes here correspond or represent 2 marbles of the same color? Well, we just looked at one of them. That was getting 2 blue marbles. And now we've worked out already that the chance of getting 2 blue marbles is 12 out of 72. Now the other way you could get 2 marbles of the same color is getting 2 green marbles. So let's follow that branch. We go, okay, probability of 2 green marbles equals, let's see, 5 out of 9 chance for the first green marble, times, then to get the second green marble, we look at this branch here, 4 out of 8. And that gives us 5 times 4 is 20, over 9 times 8 is 72 again. So these are the individual probabilities of getting either 2 blue or 2 green. So the question is, what is the probability that we will get 2 marbles of the same color? Well, since we've got 2 separate branches, it's this one and this one, we now add those 2 branches together. So the probability of 2 same color is that 12 out of 72, add 20 out of 72, which equals 32 out of 72. So that is the probability of getting 2 of the same color. Now this method here of adding 2 separate branches together is the same if it was with replacement as to whether it was without replacement. The difference for with and without replacement comes down to this set of branches here, where we have one less thing than we did before.